Assalamu alaikum. Today inshallah we will make electrolysis of sodium chloride. Sodium chloride, we have three different shapes of sodium chloride. The first of it is the molten shape, in which we will carry the same as we did before in lead bromide. The molten solution, the molten sodium chloride, we will need here a source of heat or flame to keep it in its liquid state all the process of electrolysis. Once the current will pass, so cleavage will happen here, and we will have sodium positive ions and the chloride negative ions. Migration of the sodium positive ions towards the cathode and the chloride ions towards the anode. We can easily write the half equation now. Sodium will gain one electron to discharge itself at the cathode and form the sodium metal in the form of silver spots. And of course these spots will be just synced at the bottom of the container or beaker. Why? Because it is we are using a flame here, so it will be also a molten sodium metal. The second part, which is the chloride ions, will migrate towards the oppositely charged electrode, which is anode, to discharge itself too. By two chloride ions will discharge themselves by the loss of two electrons and forming a molecule of chlorine gas. Now the properties of the products, chlorine gas. Once again, we have to know all the properties of the gases produced at the different electrodes. Chlorine is a yellowish green gas which can bleach the color of a moistened litmus paper. We finished the molten part. Now we will go to another part, which is the concentrated solution, or commercially called by brine. Once again, we will have our electrolytic cell, but here we are having a concentrated solution, which means together with the sodium chloride ions, we are having water molecules, which will have the same effect by the passage of current. Cleavage of both the sodium chloride and water molecules will happen here. So we will have sodium positive ions and hydrogen positive ions from the cleavage of water molecules. Both positive ions will migrate towards, yes, the cathode, but here we will have only one kind to be discharged. According to what? First, according to the reactivity. The most reactive positive ion, which is sodium, will remain in solution, while the other ion, which is hydrogen, will be discharged at the cathode. How? It will be discharged by gaining two electrons. Two ions of hydrogen will gain two electrons to form a hydrogen gas. Once again, we have to know the properties of the gas here. And the other part, which is the anions, chloride and hydroxide ions, will migrate towards the anode, yes, where one of them only will be discharged. Which one will be discharged here? It's the higher concentrated ion will be discharged. We are having a brine, which means we are having less amounts of water and more amounts of sodium chloride. So we are expecting chloride ions to be in higher concentration than hydroxide ions. So we are expecting the higher concentration ion to be discharged only at the anode, where two chloride ions lose two electrons to form a one molecule of chlorine gas. Now let's check our products from the electrolysis of brine. We are having two products here, gases at the different electrodes. Hydrogen gas at the cathode, which is a colorless gas, burns with a pop sound. Chlorine gas at the anode, which is a yellowish green gas. Once again, it can bleach the color of a moistened litmus paper. And we are having another important product here by the electrolysis of brine. Let's check here our solution itself. We said that hydrogen ions and chloride ions will be removed now by discharging to form the gases at the different electrodes. Remaining in solution, we are having sodium ions and hydroxide ions, which means the solution now is turning to be a basic solution of sodium hydroxide, which is one of the important products gained by the electrolysis of brine, commercially used in preparation of detergents and many other uses. So we are having another third product, which is sodium chloride in the solution itself. The other shape of sodium chloride here, the dilute solution. In dilute solution, we are having more amounts of water and less amounts of sodium chloride. Once again, by the passage of current, cleavage will happen here, and we are expecting sodium and hydrogen to migrate towards the cathode. One of them only will be discharged, which is, yes, once again, here the reactivity is controlling the discharge, and we can know all the expected discharge of positive ions through the electrochemical series, where we are having all ions are just not discharged or difficult to be discharged in preference to hydrogen. So whenever hydrogen is present, it will be discharged preferably than all other ions except for copper ions and silver. So whenever we will find copper or silver together with hydrogen, we will know that we are expecting copper and silver to be discharged in preference to hydrogen. The opposite is true in case of all other metals. Hydrogen will be discharged preferably than all other metal ions. What about the anion here? We are having chloride ions and hydroxide ions. Which one will be discharged? Once again, both will migrate towards the anode. One of them only will be discharged. We said before it's according to the concentration. Here, according to the concentration, which one is in excess? We are having dilute solution, which means hydroxide ions are in excess. So hydroxide ions will be preferably discharged than chloride ions, where 4 hydroxide ions will form 1 molecule of oxygen, 2 molecules of water, and releasing 4 electrons here. Once again, back to check our products from the electrolysis of dilute solution of sodium chloride. We are having hydrogen gas at the cathode, which is a colorless gas, burns with a pop sound, and we are having oxygen gas at the anode, which is a colorless gas that can relight a glowing splint. And here inside the solution, what's happening now? We are having the hydrogen and hydroxide, both are discharged. So what's remaining in solution is sodium chloride, which is the exactly the same solution that is, was found before the electrolysis, but removing the water molecules from the media here, it means our solution, which was at the start a dilute solution of sodium chloride, is getting more concentrated by the process of electrolysis.